Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be dealing with the 2020 Calculus BC exam uploaded by CollegeBoard. We will be dealing with a question 1 style prompt, which is why we are going to be given 25 minutes to answer a 2-part question. I've only uploaded half of it for now. It is actually parts A through G, but we will take care of the second parts as we come to them. So from here, it's a typical graph of f prime, or g prime in this case. It reads, the continuous function f is defined on the closed interval -2 to 5 and consists of 2 line segments and a quarter circle centered at the points 5, 3 as shown in the figure above. The function g is given by g of x is equal to the integral of this thing. Part A is asking us to find the average rate of change of g over the interval -2 to 5. And so the highest level of math really needed to set up Part A is really integrated 1, but the evaluation of it can get a little bit dodgy. So we'll just go ahead and say g of 5 minus g of -2 over 5 minus -2. Well, below, that gets me 7, no question there. We know that g of -2 is 0. Again, how do I know that? It's because the limits of integration will line up exactly, so I'll have 0 area. It's this g of 5 that I got to be worried about. Well, what is g of 5? G of 5 is the integral from -2 to 5 of f of t dt, and this is where the problem starts to take a bit of a dark turn. Well, let me see if I can clean this up a little bit to make sure that we know where we're going here. If everybody sees the red space underneath this triangle right here, and the red space above this triangle, those can cancel each other out, which makes the problem a little bit easier. So I really only have to evaluate the integral from 0 to 5. That'll help speed us up just a little bit here. So from 0 to 5, that would be a triangle that's partly underneath. So you know me, I like to draw shapes. So a small triangle down below with a base length of 1/2 and a height of -1. I'm going to add that to a large hunkin' triangle right here that has a base length of 3/2 because I'm going from 2 all the way back to 0, all the way back to the 1/2. And a height of 3, and then I'm going to have a square which has a side base level of 3, and it's going to subtract that quarter circle right there, which is going to be 1/4 pi r squared. So I just got to figure out what each of these things is. So what I'm going to do is I'm going to say 1/2 base times height plus 1/2 base times height plus 9 minus 1/4 pi, and the radius is 3, so 3 squared. Now actually, you can go ahead and just call him all over 7 if you wanted to, without simplifying, and then making that equal to g of 5 minus g of -2 over 5 minus -2, and that would actually be acceptable because remember, we don't have to simplify anything on the day of the AP exam. Just make sure all of your stuff is lined up. So that should take care of Part A. Part B is a little bit confusing. We're being asked to find the limit here. So B is the limit as x goes to -1 of f of x squared plus x over f prime of x minus x. All right, well, there's a lot to this. So f of x squared, if I let x squared go to -1, I'll get 1. So in reality, this x squared is heading towards 1. But the entire thing, f of 1, is heading towards something else. F of 1 is heading, well, okay, just kidding. It's actually heading towards 1. It's not heading towards something else. That is a coincidence. And then plus x. Well, that's going to be plus -1. So what I get up top is I get 0. Well, on bottom, f prime of x. Well, what is f prime of x heading towards as x goes to -1? Well, as x goes to -1, looks like we've got a -1 as our slope, so that's going to be -1 minus -1, and I get 0 on bottom. So 0 over 0, that sounds like some L'Hopital's rule in my future. We can handle L'Hopital's rule. We need to make sure we identify that we are using L'Hopital's rule. So we've got limit as x goes to -1. When I derive, I got to be careful. It's going to be f prime of x squared times 2x for chain rule, plus the derivative of x is 1 over f double prime of x minus 1. And now we just got to find out if we're in a safe position to let this limit happen. Are we? If I let f prime of x go to -1, so this would go to 1, and what is f prime? What is f prime of 1? F prime of 1, I believe, is 2, because that is the slope's value right there, so I'm going to get a 2 times 2 times -1 plus 1, right? So that's what happens when I let the limit actually happen. So what I get is I get 2 times -2, which is -4, plus 1 is going to be -3. Over, what is f double prime of x as x approaches -1? Well, that's the hard part, is that f double prime, remember this is a graph of f, so actually what you see is what you get. F double prime in the context of this is going to be the concavity of the graph right here. But what is the concavity of a line? The concavity is 0. So you get 0 minus 1, which is -1. Your limit heads to 3. Okay, let me go and clean up the board real quick, and I'll get started with C. In part C, it says, on the interval -2 to 5, find all values for x for which the graph of g has a point of inflection and explain your reasoning. Okay, well, if g of x is equal to the integral from -2 to x of f of t dt, point of inflection requires the second derivative, so we can go and find that out. Using the second fundamental theorem, I will get g prime of x equals f of x, and g double prime of x is equal to f prime of x. So from here, where f prime changes sign, or where f changes direction, is going to be where our points of inflection are going to be. In fact, I like that. I'm going to write that in our notes. So since I made the establishment, I'm going to say points of inflection occur when g double prime or f prime changes sign. Or, in other words, where g prime or f changes direction. So where does f change direction? That happens at 0 and at 2. So I can say, therefore, g will have points of inflection at x equals 0 and I totally forgot the number, 2. Pretty straightforward on C. I don't see any problems with that. All right, let's take a look at D. It says evaluate the integral of this thing, so we can do this. So this is going to be D, the integral from 2 to 4 of f prime of 6 minus 2x dx. I would say u sub. You can use rule chain if you want to. 6 minus 2x du is going to be -2 dx, which means -1/2 du is equal to 1 dx with your linkage here. Since we're using a u sub, I'll go ahead and reposition the limits of integration. I get a 2 on bottom. If I put a 4 in there, I get a -2 up top. That's going to play a role. So what I'm going to get is I'm going to get -1/2 integral from 2 to -2 of f prime of u du. Flipping the limits of integration gives me +1/2 because I have to pull out the negative. So -2 to 2 f prime of u du, which then becomes 1/2 f of 2 minus f of -2. And you just have to look at the graph to find out what those answers are going to be. You end up getting 3 minus 1. And I would go and leave him right there. So that handles it for part 1, number 1, parts A through D. Let's go ahead and get the second part up there. Give me a second. And here we are for part 2 of this 25-minute question here. It reads, a function h has derivatives of all orders for all real numbers x. A portion of the graph of h is shown above, along with the line tangent to the graph of h at x equals 0. Selected derivatives of h at x equals 0 are given in the table above. Let R be the region bounded by the graphs of h, the line tangent to h at x equals 0, and the line x equals 1 as shown in the figure above. Part E says, write a third-degree Taylor polynomial for h about x equals 0. Okay, how do we do that? Well, you guys know me by now. Whenever it comes to writing Taylor and Maclaurin polynomials, I always write the generic one first, and then I plug in the pieces after the fact. So since it's h and it's about x equals 0, it'll be h of 0 plus h, whoops, not f, h prime of 0, x, plus h double prime of 0, x squared over 2 factorial, plus h triple prime of 0, x cubed over 3 factorial, and I can stop right there and start plugging in certain values. So what is h of 0? Well, that happens when the graph crosses the y-axis, right? So that's going to be 3. What is h prime of 0? Well, that's the slope of h at 0. Luckily, even though we don't know what this graph is, they give us a line that's tangent to the curve at 0, which means the slopes will be equal. So if I find the slope of the line, I should be able to find the slope of the curve because they will be the same. The slope of the line looks like it's -2 by using our slope triangles from integrated 2. Or integrated 1, rather. So that's minus 2x. And then plus, well, what is h double prime of 0? Well, I think they gave me that, right? They gave me that. At the second derivative, that would be 3. And that's going to be times x squared over 2 factorial. And then plus, finally, or rather when I say plus, I really mean minus 23 over 2 x cubed over 3 factorial. The last two coefficients, again, I got from just using the table. All right, part F. Write but do not evaluate an integral expression that gives the volume of the solid when r is rotated about the horizontal line, y equals -2. Okay, so y equals -2 is going to be like down here. And we're rotating this way. It's a dx integral that's going to be hollow. So from here, pretty straightforward, I think. Pi, limits of integration are from 0 to 1. I'm going to go and draw my little blue guy right here. And I apologize for drawing on the problem, but the blue guy is going to integrate the thing furthest away from him, so that's going to be the function, right? That's going to be h of x, but just evaluating the h of x gets me to here, but I need the extra space, so he's going to be h of x plus 2 squared dx. But then we all know the red guy comes up and says, whoa, back up, bucko, we don't want to get all that. He's going to integrate the thing closest to him, which is going to be the line. And we're going to subtract that integral. So from 0 to 1 with a pi, the line, well, I need the equation of that line. Well, I know that his slope is -2, so he's going to be -2x plus 3, because the y-intercept is 3, but that only gets me the line to the x-axis. I want to put 2 more on top of that, square it, slap on a dx. Since we're not supposed to evaluate it, we can leave it right there. I'm all about leaving it right there. Okay, so next, G. Integral from 1 to infinity of 1 over x to the p plus 1. I'm going to go and call him x to the negative p minus 1. Actually, I'll back him up 1. The negative version of p plus 1. And it says where p is greater than 0. The reason why they're specifying why p has to be greater than 0 is because they are trying to tell you that under no circumstances will this thing integrate into a logarithm. There's not going to be an ln there, right? And so just make sure we keep that in mind. And so from here, what do we got? Let's go ahead and just simplify this thing a little bit. It's the integral from 1 to infinity of x to the negative p minus 1 dx. And since one of our limits of integration is infinity, we can then say that this is an improper integral. So the limit as k goes to infinity of the integral from 1 to k of x to the negative p, minus 1 dx. And then let's just go and evaluate it. So that's going to be x to the negative p minus 1 plus 1, right? Because whenever we do reverse power rule, we add 1 to the exponent. And that's going to be over the new founded exponent. And that's going to be evaluated on 1 to k. Please don't forget that limit. These guys are going to cancel each other out, giving me the limit as k goes to infinity of x over negative p on 1 to k. Now from here, what I'm going to do is I'm actually going to factor out that negative 1 over p. I don't like constants. So I'm going to go ahead and say negative 1 over p times the limit as k goes to infinity of, I forgot about that negative p here. And I'm also going to kick that 1 over x to the bottom and make his exponent positive again on 1 to k. So when I evaluate him, I'm actually going to get negative 1 over p times the limit as k goes to infinity of 1 over k to the p minus 1 over 1 to the p. So 1 over 1. Sweet. And now I feel like I'm in a safe position to let this limit happen. As k goes to infinity, this dude goes to 0. The negative 1 over p will multiply in, giving me ultimately negative 1 over p times negative 1 is 1 over p. And I believe that is going to wrap it up for this question. Hopefully that makes sense. Let's go and check out our time, see how we did. 16 minutes. Now, of course, I feel like I'm kind of cheating because I paused the video to upload the questions and stuff like that. But as always, feel free to leave comments and questions in the comments area, and I will see you in the next episode.